Hello everybody, it has been a while, but I'm back, and today I'm gonna build something again in Rust. This time not on an ESP32, I'm just going to build it on my MacBook, but it should work obviously on every computer. And what I want to build is an MP3 player. So that's a player that can play some songs, and you can control it in a multitude of ways. But one of them is UART, so that's serial controller, and it is the device you see here on my left. I paid €5 for it. It's way overpriced. You can't get it for much less. But this one was quick, and it has a not so impressive 4 megabyte of flash memory. You can connect it to your computer, use it like a USB stick. You put on a song. You can call those songs 00001.mp3 and 2 and 4, etc. So then you have like a playlist and you can play around with that. That wiring that thing up. First of all, before we can do that, we need a UART to USB device, and that's something like this. So I got one of those, also not terribly expensive, and that basically bridges between USB and UART. So UART is like the old school serial ports. If you are old like me, you will remember the days of null modem cables that you could get computers to talk to each other before networks were a thing for most people. And also for modems. If you want to have a dial-up connection, you need to first connect to your modem. You're using a very similar system than this, and then you connect to something, some internet access, and then you had network. But up to that point, that's how it worked. And it surprises me how much of that technology and also just the commands and everything is still quite familiar. I had not expected that. So also for like GSM chips you can use to create data connections, GPS chips you control with very similar commands. But in any case, so this is one USB port. You put that into your computer. It's just normal USB. And then it has 5 pins in this case. The 3.3 volt I don't use. You have a transmit pin, a receive pin. So TX is transmit, RX is receive. Ground is ground. +5 is obviously +5 volts. So you can wire that up to something. And you have to remember that if you wired it up to something, some other UART, then you need to cross the cables between the transmit and the receive. So the transmit pin should go on the receive pin of whatever else it is you are talking to. Okay, so if we go back to our MP3 player, let's quickly go through all the pins that are important. So we have here the TX and RX, so that's the transmit and receive pins. These are general I/O pins. We're not going to use them at all. Here is a ground pin, so we're going to connect it to the ground of the USB. Speaker plus, speaker minus, so we're going to connect that to the output speaker. And these ones I don't really know. 3.3 volt, we can connect to the 3.3 line of the USB, but I think we don't really need it, so we can leave it out. And then we have the 5 volt, we can connect to the 5 volt. And these three are configurations and what kind of mode it is by pulling them high or low. So I thought this was a nice place to start with UART, because it's a pretty simple device and it has a pretty simple commands. But wiring was a little bit more involved than I kind of liked, but here we are. So if I take the user description for UART, so this is how you wire this chip up if you want to use UART connections. So that adds some complications here and there. So here we see the UART pins we talked about before. So the TX here goes to the RX of the thing you connect to, and vice versa, so they're crossed. So that's for so far so good, but they also say you should have a 1K resistor in there. And I'm not sure if it's about the 5 volt versus 3.3, I'm not sure, but they say it has to be done, so I won't argue. Speaker, pretty straightforward, plus and minus wire. Here they connected both the 3.3 and the 5, so fair enough. And then here you have the mode, and there are different modes. You can also have it like play whenever you pull one pin high, and then for each song. But I wanted the UART, so I'm not going to do that. So to put it in UART mode, I have to pull con 3 high, con 2 low, and con 1 low as well. So that's what you see here. However, there's also, you need to have a so-called pull-down resistor, so a resistor that limits the current, but does pull it down to be in a clearly low or high position. So, these I need to add as well. And that is it. So, I wired that up, and I warn you, it's not pretty. So, this is, let me point with something. So this is like a USB-C converter, goes to my MacBook. This is my UART converter, and I wired that to this breadboard. This is the MP3. I flipped it around. I put the headers on the other side, so here you could see what's on the pins. These three transistors are the pull-down resistors, so the 10K ones that configure to use UART. On the other hand, there, on the other side, you see here, yeah, you can't really see them well below the red wire. There are the two resistors. They are going to the TX and the RX pins. And here I have a truly, oh, it's magnetic, a truly pathetic little speaker. I knew it would be bad, but it's worse. So this. I was kind of amazed that it worked, to be honest, because this thing, so much wiring, so much things I could do wrong, and it worked first time, weirdly, so that's something. But now, let's not look at this for a moment, and let's get back to some actual programming. So, now what? So, if I read on, you have to have some other settings in your serial communication, because it is a very basic protocol. You need to first know with which protocol settings you speak. It can't figure it out itself, because if you get this wrong, the data will be wrong, and they just don't know. You just get gibberish on the line. So you need to get this right. So that's this important one, 9600 bps. So that's bits per second. So that's not a lot. 8 data bits, 1 stop bit, no check. And this is pretty standard. I think I see this pretty much always. Only the baud rate can vary quite significantly. Then you need to figure out what bytes mean, right? So this opens up a connection where you can send and receive. You can send bytes in both directions, and the other end will receive. It's like a TCP connection in that sense. But then you need to add semantics to it. And that's in hexadecimal. So the first byte, so that's hexadecimal, two hexadecimal digits is always AA. Then you have a type that indicates different commands. Then the numbers of bytes in the command, and then the data, and then the CRC. So most commands are pretty simple, as you will see, but some are a little bit more complicated, so that's why you have those. CRC is a little bit tricky again. So you take all the data you have, all the bytes, so the AA and command type and everything, you add it all up, modulo a byte size, so 256. And then you take the lower bytes. So basically, this prevents some janky data to make the machine act up. So if this is wrong, it will ignore the command. So let's look at an example of a command. Where do we go? Check the play state. I'm not interested in the play state. Let's take the most basic command, play. So AA, that's the prefix of every command. 02 is the play command. Yeah, that's what it says here. No extra data. And then the checksum. And that's AA plus 02 is AC plus 00 is still AC. So that's correct. And this is the command that starts playing. And the command that stops playing is also AA, of course, because all the commands are 03, no data, and then the final CRC is 80. So if we send this through the line, it should start playing. Send this through the line, it should stop playing. All right, so let's start there. Let's create a new. Let's do some Rust. Oh, now first, let's look for the device. So the device is for at least Macs and Linux systems in /dev, and these class of device always have a name starting with CU. And you see a few things in here. Some Bluetooth thing. This is the sound bar I occasionally use, the other sound system. But this is the one we're talking about, the USB serial. If I unplug it, and I do it again, CU. Then it's gone, right? And then we'll plug it back in. Still not there. Now it's there. So that's generally how you discover USB devices, by just unplugging them and seeing which one disappears. On the Windows it's a little bit different, but also not that much different. So this is the device for the operating system we need to talk to if we want to talk to our MP3 player. So let's create a new Rust project, cargo new, and we call it Rust UART. And we're going to code. Yeah, this is an excellent time to upgrade. Not that bad. Okay. Here we go. So we need a library for that. Let's look one up. Rust. Let's say serial port. I guess this one will do. Let's check crates.io. So this is how you can list ports. That sounds very useful. And you can create a new port with a baud rate and open the port and then write something to the port. So that should do something, right? That should not be too hard. So let's see how that goes. Cargo add serial port. Well, let's do that. Okay, let's go to the code. Let's first copy that example to list the ports. Okay, let's run this thing, see if that works. Excellent. So yeah, we find the exact same. They also have a TTI variant, so that's like a terminal version. Not sure what the difference is, but I always use the CU ones. So this just lists the devices, so that's fine. Let's take the next example, open the port. Import this thing. Now we have a port. We need to get the right one. This one. And 9600. I think all the other settings are just defaults. So now we have a port. I mean, we can still run it, but I don't think it will tell us anything because it doesn't respond in any meaningful way. And then you can write to that port. Okay, so port needs to be mutable, of course. Now I don't think this will do anything because it will not understand this command. Nope. But let's see. So let's get back to the manual. We had this command, right? Let's take it here, paste it as a comment. So instead of this, let's create an array. So let's put 4. So we put in 0 U8s, and we take 4 of them. So now we create an array of 4 bytes. And let's just very naively just color those. I'm not sure if you can actually just enter them straight away as literals, mutable of course. So let's say output 0 is how do you create the literal 0xAA, I suppose. Okay, let's do the other 3. So 1, 2, 3, AA 0, 2, 0, 0, and AC. And then we need to borrow that because it wants a slice. And it's like a unwrap, and then it has error, and that's fine. So let us run this thing. And I don't know if you can hear it. It plays some silly piano tune I uploaded to the board. It's oh. I think you should be able to hear it. I googled for royalty-free music, so I hope I don't get into trouble for this. But yeah, that works. So that wasn't actually that hard. I think let me unplug it. Yeah. I think the biggest problem is that up until that all of this works, you have 0 feedback if you're on the right way. If you got all the resistors right, if you got the wiring right, there is 0 feedback for that from the thing until this. So now we have done this. Let's try to make this a little bit nicer and rustier in a sense. So what I would like to do is to create a very basic driver which we can send commands, and that is a little bit nicer to use than just pushing a bunch of bytes to a device. So let's get started. First, let's create a struct for the MP3 player. What's the chip version? DYSV1. Why not? Let's not put my dash in there. That's confusing, and it doesn't like that. Something like that. I guess it also doesn't like the capitalization. Something like that. And let's give it ownership of that port. So we don't need to list the ports anymore. That works. We have a serial port, and if I show it, it's boxed in, so the dynamic box to trade serial port. Okay, so we call here a port box dynamic serial port. And also it will need some kind of buffer to send commands. I don't know exactly how complicated they can get. I didn't check all of them. Let's start with, like, I don't know, 8 bytes. That should do. Like this. Add the semicolon. So now we have a thing that has a port and a buffer. So I think now it should be able to send commands. Okay, let's add some members to it. The name is kind of horrible though. But hey. Create a constructor. That constructor should take a port of the same type. Return the self. With the port and buffer. 8 of them. So now we construct one, and let's create a method to play. So function play, which takes a mutable self. Right, I don't need to return type. So because I need to write to the port, and then I need mutable access for that. And basically what I could do is write these bytes in the buffer. Just to get started, right? So I could take self.buffer, and I send a slice of those 4, because the buffer is bigger than that, to the serial port. So I do well, I could copy this one as well. Self.buffer 0 into 3. Self.port. Okay, let's see if that worked. So instead of messing with the port directly, we're going to construct a driver. That driver equals whatever that name was, new, and we add that port in. Need to make it mutable, and we say driver dot play. We should do error handling as well, but exercise to the reader. So let's comment this out and see if this isn't mutable anymore. See if this works. Plug this thing back in. That did nothing. Let's see. Maybe I was too quick. Let's re-add this part to verify if that still works. To make this one mutable again. Yeah, it still plays, so I'll cycle it. So that works. So there is something wrong in this code. I wonder if there is it closes. No, it does exactly the same thing, right? I was thinking like if the process terminates before it's flushed the buffer or something like that. But it really does look like it does the exact same thing. AA0200 AC 0 to until 3 exclusive. Well, rule 1 of debugging. Try again. Oh wait, there's something wrong. Forgot one. I am a little bit confused. Let me see, if I just take 4 bytes. Oh. 4 bytes. And then I could just use the whole thing, right? And dot like this. Now it works. I really hope you guys can hear it, because otherwise it's a little bit. So if I change it to this, it's different. Really? That seems to be the case. One more time. these are the exact same bytes, right? These are all the bytes that are there, and that seems a very sensible I'm at a loss how that can make a difference. Alright. Let's have a look at some more commands. I need to, but I do need to figure this one out because this is kind of ridiculous. On a slice of 4 bytes from 0 until 3 should be exactly the same as the entire buffer, right? I would think. It's initialized to 0. And I change all those individual ones. If I just do this, this does work. Okay, and if I make it a bit bigger now, I think this should still work. Yeah. I don't quite understand, but at least we have it running again. Okay, so let's look at some more commands. In the manual. So we have play, we have stop. We can add that one as well. I'll just add it here. And this was play. What else do we have? Like next, previous. Yeah, this is not very interesting. Let's do the volume setting. That's a cute one. So that looks like this. So we have AA as command header, command 13, and we have one piece of data. So 1 byte of data. That's the volume in 20 steps. So 0 to 20, I suppose. And then the error correction code. So the sum of those modulo to 56. Okay, so we can obviously bang this out and create methods for all of them. But there is, of course, the issue with the volume that we do need to calculate that CRC depending on what volume we give it. So we have to do that afterwards, in a sense. So let's make our driver a little bit more sophisticated to let it do 2 more things. First of all, to have a generic send command thing that will just we can reuse, that we don't have to copy paste this all over the place, and that we can calculate that CRC. All right, so let's start with the CRC. So function, what's the easiest way? Let's do it like this. Add CRC that will add the CRC bit to the buffer. So we have a mutable self, of course. And we will need to know how big the command was. So let's call it size, the command size. And that's going to be a U size. And what we need to do is we start at 0 and we go to the command size and we're going to add the CRC. So let's start with creating a mutable CRC total in a sense, and that's start at 0 and this U8. And then we're going to loop over the buffer until we found our command size, right? So we're going to do for, let's call it I in self.buffer. No, I in 0 until command size. So we're going to take all the bytes and we're going to increment the CRC, but it's in we do it in a special way. Do a wrapping add, so we can keep on adding and it will go back to 0 whenever it overflows. And that's exactly what we want here. So we do a wrapping add of the value of the buffer, so self.buffer in I, and we assign that to CRC because that's what it returns. So now we have a total after this loop completes, and then we need to put it on that address as the last one. So we do self.buffer and we go to command size and we assign it to CRC. So what this does, we have to take into consideration that this command size shouldn't be larger than 8 or 7 actually, because then it overflows, but I don't think it does. Alright, so that's now we can calculate it. In the like for these ones we didn't really need to, right? Because there is no data field, so the command for play is always exactly going to be these 4 bytes. Let's create a send command function. Send command takes a mutable self. We take a command sort of template in a sense. So yeah, let us take one step back and start with creating the set volume, because that's the one that makes it interesting. Set volume, mutable self like all the others, and also a volume. And that's U8. And that U8 is from 0 to like 20 hex, I think. Something like that. So we want to call a self.send command or something, and then create a sort of template of a series of bytes, and then that send command can add it to the buffer. So let's create a constant for that. Yeah, we can create a constant for the others as well. Yeah, let's do that first. I've changed my mind all the time, sorry. Let's create a constant. play, and that's of type an array of U8. And let's say that we only need 3 bytes for that. And I think we can just initialize it here. And we can create literal, so this one, this one, oh, and this one. Yeah, that works. So now we have a sort of command template of those this command, and then we could pass that to our send command, and that will add the CRC. In this case, it's always going to be this, so it's not super useful, but for the set volume or other ones, it will be. So let's continue with our set command. So what does it need? It needs a slice of U8. So that's something like this, U8. Let's do that. So then we can replace the contents of this one with self.send command. We add in play, or reference to play. So that nearly works, because we want, in this case, so in this case it's fine because we don't have any data, but for the set volume we're going to do the same thing, right? Let's create another constant for a set volume. So that was also AA, it was 13, I think. 13, and then 1 data, and then the actual data, so this one, and then the checksum. So I'll just add 0 for the data because I do need the space for it, and it's called like set volume. And that's a little bit bigger, that's 4. So set volume, send command, set volume. But what do we do with that volume? Because we need to set it into the buffer after we copy this one in, and then we still need to add the CRC. So we need to have the opportunity to copy in data. One way to do it, which I think is works pretty well in Rust, is to use a closure for that. So then it gets a little bit more into the weeds in how we're going to do that. So we want to add a closure here, so some kind of function, and that we can that will be called back to copy in the volume, if that makes sense to you. So I'm gonna add a function here, like a closure. Let's say like we get a mutable borrow of the buffer in the closure, and then we're gonna say that we want to copy the volume to buffer number where the data is. So that's 3 is volume. Yeah, it's a I mean, we didn't add the closure at all. So we will need to define that closure here. So a function that takes a mutable slice of U8, and it returns nothing in particular. Let me see. And that's not correct, because we need to add it like this, and we need to give it a parameters. Okay, so because we're passing in a trait, we need to box it. So we do box dynamic here. I think it doesn't like these. Am I correct? Getting there. I suppose. Is that necessary? It shouldn't be, right? Let's give it a type just to appease it. Well, okay, I need to, of course, create a box new with this thing. Are we calling the right? We need to have the mutable one. The not so famous Rust error messages. Why is this not working? This seems to work fine, but I'm still a bit at a loss why it needed. Oh wait. Okay, so that was just messed up. Now we're getting there. So I already had the feeling I shouldn't need to give type annotations there. So now it says volume doesn't live long enough because I captured in the closure, and doesn't like that because I need to add move here. Then it takes ownerships of it, and then we are good. So now we change that signature. So for play, for example, we need to add an empty closure. We could also make it an option, of course. It's a little bit cleaner, I think. Underscore. Like this, I think. So this is like a non-closure. So we have these. Now we need to do the actual sending of the command. So we need to copy the command into the buffer. Then we need to call this function the closure we got. So the caller is allowed to add their data, and then we need to call the add the CRC. So let's do self.buffer, and then we need to copy only the length of the command, right? So we go from 0 to the command dot length. I have the feeling there is a cleaner way of doing that. And then we can do copy from slice. And for that, we refer to the command. So that this will just take the first the length of the command, which should be smaller than the buffer, and copies that into there. Now let's call that closure we got. Then need to go more. Okay, make it mutable. So now the data has been entered, and then the next thing we can do is to add the CRC. So dot add CRC, and we just take the command dot length again, and then that add CRC will loop through the command we sent, including the data, and then put the CRC value in the next one. All right. So let's, we didn't ever implement the stop one. So let's do that, so we can also stop it. There's one digit different. AA04 AE. And the checksum should be correct. And now the different commands are really short, right? They're basically all one-liners, which is nice. The stuff we did before is pretty error prone. Let's do a quick test. We do a loop. We say driver play. We sleep for a duration from seconds, let's say 2 seconds, and then we stop, and we sleep again for 2 seconds. So it will play for 2 seconds and be silent for 2 seconds. Then we see if that at least worked. It didn't. Maybe I need to replug. Try it again. It doesn't seem to work. Let us figure it out. Let's see what it sends to the command. So I don't want to set up all logging and everything. So let's do print line. I forgot. Something with an X to print hexadecimal. Let's see. Rust print hex value. There was another one. I guess this is the one. Because I think you should be able to, and then we go from 0 until command that length. Now we need to be inclusive though. That looks a little bit better. Let's see what it says. It's not exactly what I had in mind, but it should be correct, right? Or did I forget to actually send it? Yeah, that's kind of dumb. Alright. So the actual writing the buffer to the port is what I forgot. And then it doesn't work. So self.port, write the self.buffer. Yeah, exactly the same as this actually. Let's see what this does. Absolutely nothing. Let me replug it just to be sure. Yeah. It does work. If you maybe you can hear. You just hear the first note, and that's I think because it has a bit of a delay starting, and then there is very little left of the 2 seconds. Let's make it 3 seconds. And run this. So now we have a bit more. Now it says nothing again. Yeah, so it does work. Let's try to set the volume. Let's do something like this. We start playing, we don't need to stop, and then we go for I in 0 until 20, driver, set volume to I, and then loop that. Then say get it outside the loop, and then sleep maybe something like that. So now maybe a little bit less from milli, so it goes from softest to loudest in 10 seconds, or half a second. Let's see. I don't hear anything. I think I need to replug it. Yeah, I do hear it. So I have the feeling it was 20 hexadecimal, I think. So that should give it a bit more legs, because it was now even softer than before. Let's try that again. So now it's really soft. Now it's at, I can hear it now. And then goes to 0 again. So that works. It's a bit of work, but we did everything in I don't know, an hour or something. And I think it's nice to see that you don't need to be afraid of doing this kind of stuff, right? And with this bit of software engineering, we got a driver that's pretty nice to work with, right? We have easy to initialize. You just pass it the port, and then you can do the play and set volume, and then you can, if you want, go through all the commands that are out there to select songs and equalizer mode, although I'm don't think I'm gonna be impressed. But yeah, writing a driver for a UART is no magic. It's not that hard, and even quite possible to make it pretty nice to work with. So I think that's enough for today. Thank you for listening, and let me know in the comments what you think, and if you have ideas of what else to do in this area, if you have ideas. And otherwise, please leave a like, and talk to you soon.